wrap up this section on graphs and charts and diagrams that are used to show uncertainty or distributions in your data by talking about error bars. Now, error bars aren't a specific graph or chart. They're really a technique that can be used in all sorts of different chart types, from bar charts to scatter plots to line charts. And so to help us understand more about what error bars are and when to use them and how to use them appropriately, we have Xan Gregg from the SAS Institute to help us learn more. So I'm going to turn it over to Xan so you can learn more about error bars.
Thanks, John. Error bars are a way to provide context to summarize values in a graph. A lot of times we can't show all of our data, either because there's too much of it or it's too noisy and it takes away from our central message. So we show a mean or several means to represent the central tendency of each group that we're showing. But now the reader does not have a sense of the variation that went into computing that mean. It could be quite a bit or quite a small amount. So that's where error bars come in. They help augment a summary value to provide some indication of the variation. Error bars, I think, have three really nice features. For one, they get along well with other chart types. So you can represent your summary values however you like, with dots or a connected line or with bars. And you can apply error bars on top of any of those to add some information about the variation. Secondly, error bars have a really distinctive appearance. You can recognize them as a line extending above and below the summary value, often with a T-cap on the end. So that's universally recognized, I think, as an error bar. And finally, they have a nice or an obvious interpretation, which is mostly correct. That is, you see it go above and below the summary value, and it's showing variation above and below the summary value. And as you compare lengths, short error bars are going to represent lower variation, less variation than longer error bars. So it's got all that going for it. But there is one tricky piece of it, and that's is where the flexibility becomes a little bit of a liability, because the same error bar graphic element can be used to represent lots of different measures of variation. So you can use error bars to represent the entire range of data from low to high. It can represent some change from the mean, such as using a plus or minus standard deviation of the data, or it could be standard deviation of the mean, or it could be a statistical confidence interval, which is usually 95% is what you see most often. So any of those or other custom things could be what's the math behind the error bar. So that means when you create a graph with error bars, you have to first decide what kind of value to represent, and secondly, be sure to communicate that in the chart, in the footer or the caption for the chart, so the reader can know. So let's look at an example that illustrates some of those points. This is a journal graph from a PLOS One journal showing student scores for reading and math test, and it's broken down by anxiety level. So the anxiety level is on the x-axis. There's just 4 different groups from low to high, and there's 2 different kind of tests, reading and math, and the test scores are on the y-axis. So we can see the line. There's really 4 points for each line. There's the 4 means, the mean for each group, and each mean has an error bar to indicate the variation. So even without knowing what kind of variation is being represented, we can get some sense of the data. We can tell, for instance, that the high anxiety group has a lot more variation than the other groups. So we should be less certain about those mean values and whether, are they different from each other? Are they different from the other values? It's harder to be certain. And the other groups all have similar levels of variation, whatever it is. And so they would be easier to compare as a group in a statistical test. So now we can look at the small print if we really want to figure out what we can, how to really interpret the confidence or the level of the error bars. And we see in this case, each error bar represents a standard error of the mean. And so that's about half what a 95% confidence interval would be. So if we if we want to imagine what the effect of that level would be. And so now we can sort of get a little bit of understanding of what the variation is in relation to the change. So for instance, in the reading scores, they're not going down that much compared to that standard error of the mean. So, it's going to be harder to make a statistical case for that getting lower. Whereas the math scores are, going down at least several lengths of that variation, so it will be well covered by the 95% confidence interval. So there's more of a case there if we want to investigate further. So that's a little bit on error bars. Back to you, John.
And thanks to Xan for that great review of error bars and when to use them and how to use them. I'm sure this is a technique you've used in your own work, so now you probably know a little bit more about how to do so. So next time on the One Chart at a Day video series, we're going to turn to our next data category. So come back tomorrow so you can learn more about how to effectively visualize your own data.